The second type of transformation we will look at is called a reflection.
When will my reflection?
When we translated a figure, we moved it side to side, up and down. But when we reflect a figure, that's a flip across a line that's acting as a mirror. Once we've figured out and defined what our mirror line is, then we can understand how to reflect across it. A reflection is a transformation that uses a line like a mirror to reflect a figure. The mirror line is called the line of reflection. Okay, so when we're talking about reflection, we're basically flipping it over a specific line, that line of reflection. A reflection in line M that we see here in this image maps every point P to a point P prime, so that for each point one of the following properties is true. That if P is not on M, so it's not on the line, then M is the perpendicular bisector of this segment P prime. Okay? And so we can see here that these are congruent segments because this line M is perpendicular bisector to it. And so we see that P is the same distance from line M as P prime is. Okay? So basically what we're seeing here is that the point P, when it's been reflected, its reflected point is the same distance from that line of reflection. If P is on the line, okay, then P prime is also on the line. Okay. If P is on the line M, then P is the same thing or equal to P prime. Okay. So let's look at some examples where we're reflecting these figures. And again, the main thing we're wanting to see there is that when we reflect a point or a figure, the points in a figure are the same distance from that line of reflection as the original image. Let's look at number 1 here. We have this triangle ABC with vertices A13, B52, and C21. And we're going to reflect it in each of these different situations that we see here on 1 through 4. So let's start by graphing the triangle. A is at 1,3, B at 5,2, and C 2,1. Smaller. And we're going to reflect it in the x-axis. Okay, so here's our x-axis, right? The horizontal axis that goes side to side. Okay? And if we're reflecting in the x-axis, that means we're flipping over the x-axis, and so that x-axis is our line of reflection. Okay? And so however far our pre-image points are from the line of reflection, however far they are from that line of reflection, is the same distance on the other side of the x-axis that the image points would be. So if I graph the image here, if A is 1, 2, 3 points from the x-axis, then I would go 1, 2, 3, and that would be A prime. Same thing for B and C. B is 1, 2 from the x-axis, and so B prime would be 1, 2. And C is just 1, and so on the other side of the x-axis, there's C prime. And so because with reflections, the points in the pre-image are the same distance from the line of reflection as the points in the image, okay, we can just count on those grid lines, okay, do those bunny hops that we've talked about. And so this is the reflected image, of our original triangle. All right, let's look at another one. Let's look at when we reflect in the y-axis. Okay, so we start with the same image at 1, 3, 5, 2, 2, 1. And we're going to reflect it in the y-axis. So that means we're reflecting it across this axis right here, the up and down axis. And so however far these points are from that axis is the same distance that their image points will be. So A is just 1 point or 1 jump away from the y-axis, and so A prime would be over here. B is 1, 2, 3, 4, 5. Okay, so we'll do 1, 2, 3, 4, 5 on the other side of the y-axis in the same direction, right? We're just flipping over that that y-axis. And 2 is 2 jumps, or C is 2 jumps away, and so it'll be 2 jumps to the left over here. Okay, so here's A prime, B prime, and C prime when it's reflected in the y-axis. Okay, so we're reflecting across the y-axis. All right, so let's continue with those examples. Let's look at another one, example 3. We have the same triangle. Okay. A is at 1, 3. B is at 5, 2. C is at 2, 1. And so this time we're going to reflect in the line y equals 4. Okay? So we're going to reflect across that line y equals 4. So I'm going to use a red line. And so y equals 4 is right here. Okay? Y equals 4 is right here. And so we're going to reflect across this line. And I'm going to draw a red dotted line to remind myself what I'm reflecting across of, so that it might be easier to count. And you don't necessarily have to draw that line, but it can be easier to figure out where am I reflecting across, or just remind yourself of that. Okay? And so I'm going to reflect across that line y equals 4. So I'll do the same thing that I was doing. The distance from the pre-image points to that line of reflection should be the same for the image. So A is just from A up to this line y equals 4 is just 1 point, and so I'd go 1 point above that, flip it across. I need to erase that. And there's A prime. For B, it's 2, so I'd go up 2 over here. There's B prime. And C is 1, 2, 3, so I go 1, 2, 3. C prime. So again, you can see how they're the same distance from this line of reflection. Let's do example 4. Here we're reflecting across the line x equals 4. So we have our same triangle, A, B, C. ABC, and we're going to reflect across the line x equal to 4. Well, that line is right here, right? Passes through 4 on the x-axis, x equal to 4. Okay? So I'm going to do the same thing that I did on the last one. I'm going to draw that line, that dotted line, to remind myself that that's where I'm reflecting. And you can see that it even passes through the triangle, right? That's okay. You know, it doesn't have to be just on one side, but you'll notice that when we flip it, it doesn't just completely flip to the other side, right? It's actually still, the line is still going to pass through the triangle. Okay, so let's look at how this works out. So A here is still 1, 2, 3 hops from our line of reflection. So I'll do 1, 2, 3 over there. Okay, so there's A prime. B is on the other side of the line of reflection, but it's still 1 away. It's 1 there, and so I'm going to do 1 in the opposite direction. Okay, over there. So here's B prime. I'm going to clean this up. It might be easier to see. Except I don't want to lose C. I just thought about that. So I'll clean it up in a second. So C is 1, 2 from the line of reflection. So we'll do 1, 2 over there. And that's C prime. Now, make that a little neater. And there's C prime. Okay. So you can see how in that one, because the line of reflection went through the figures are still on top of each other and how they're reflected in that case. So when we're working with this line of reflection and trying to reflect a figure, we're needing to know how far are those points from that line of reflection, because that will tell us how far away they are in the image. If you're paying really close attention to the coordinate points in those pre-image and image examples of reflection, then you may have started to notice a pattern. These patterns help us develop rules for reflecting points across specific lines. We can use these rules to make things a little bit simpler. Let's go ahead and look at them now. So obviously graphing all of those figures by counting the boxes, looking at the diagonals, with all the points, it gets a little tedious. And so there is a quicker, simpler way that we learn. So if you were paying attention, you probably noticed the pattern with some of those points. So let's look at what those rules are for reflection. So if we have a point AB, and it's being reflected in the x-axis, then what we notice is that when it's reflected in the x-axis, the first value, the A, stays the same, and the second value just becomes the opposite sign. So whatever that second number is, it becomes the opposite sign, and that's what the point would be reflected in the x-axis. If it's reflected in the y-axis, that first value switches its sign, okay, and the second value stays the same. Notice that I'm saying it's switching its sign. Okay? We see that negative in front of the A and that negative in front of the B. That doesn't just mean that it's automatically negative. That means it's switching its sign. So if it's positive, it becomes negative. If it's negative, it becomes positive. All right, and then if the points are being reflected in the line y equals x, that diagonal line we looked at, then its image points, they flip. Okay? So it's B and then A. And if it's being reflected in the line y equals negative x with that negative slope, then they flip and they also change signs. Okay, so it's negative B, negative A. So that's a quicker way of recognizing where the reflection or where the image is going to be, because you can look at each of the points and just change their signs or change flip them, and then you can graph those points onto the coordinate plane.